Now, if we are graphing secant of theta, what you have to realize for secant is it's the reciprocal of cosine. So let's write that down, that it's the reciprocal of y equals cosine theta. We're using theta instead of x. So that is a reciprocal of this. So if it's a reciprocal, what we're really going to help us to graph this is to graph cosine. So watch this. I'm going to graph cosine right here. So cosine would start right here, drop down through there, hit right there, come up like that. So let's draw that in. It's going to start here, halfway through there, and there's the end of the period. So it's going to go like this. We're going to do a dotted line because it's not really part of the graph. It just helps us. But that right there, that blue line depicts cosine. And if you look at it carefully, do you notice that in this interval right here, do you see how it flips? It's the reciprocal. Do you see here how it's the flip, the reciprocal? Can you see here how it's the reciprocal, the flip of the graph? So if we learn how to graph cosine and just take it and flip it, that would be secant. Now, there is an interesting thing is, why are there asymptotes at these 2 points? Well, what's the reciprocal of 0? Undefined. So whenever you have a 0, it's undefined. So let's write that down. That asymptotes, what they come up is when they come up when cosine theta equals 0. Or at the x-intercepts. It's the same thing. Or the zeros. So anytime you have a 0, an x-intercept, or cosine being 0, the graph will have an asymptote because it's reciprocal of cosine. So we are now going to take this idea, this knowledge we have, to graph this secant graph. So I'm going to start with my amplitude, which is 1.5, but the negative means it's going to be upside down. So just as a reminder, the cosine is going to look like this. It'll look like that. And our period, where a period is 2 pi divided by 1, because isn't there a 1 right there? So 2 pi divided by 1 is 2 pi. So we're going to graph a cosine graph from 0 to 2 pi. So I'm going to call this halfway. So I'm going to call right here 2 pi. I'm going to go by, so I can break it up in fourths. So I'm going to call this halfway, this 2 pi. And since we want to go 1.5, I'm going to go up by ones. So it's going to be 1 and 2 and -1 and -2. And if I'm drawing an upside down cosine, aren't we going to start at -1.5 right there? And won't we also end at -1.5 right there? So don't we start and end at -1.5 of a cosine? Halfway, aren't we going to go up +1.5? And there we're getting our cosine graph started. Halfway, what's going to happen halfway? Doesn't it hit the x-axis? And you remember over here, what happens when it hits the x-axis? We have an asymptote. So what we're going to have here is halfway through, we are going to have asymptotes right here. So wherever it normally would have hit the x-axis are asymptotes. Let me sketch this. Here's my cosine graph. It'll help you. We sketch the cosine graph through all that. So there's my cosine graph. Where it hits the x-axis are my asymptotes. To graph a reciprocal, isn't it look like a flip? So if I were to flip this, are you okay? That looks like my graph. It looks like this, so if I flip it, won't it go down? If my graph looks like that, if I flip it, won't it go like that? And won't this one go like that? Do you see how we flipped every single graph over? Have my asymptotes, and we have now graphed a secant function. So for this one, let's do our amplitude and period. Our amplitude is right there, 1. And our period, well, it's 2 pi divided by 2, which would be pi, because those disappear. So that's my period, that's my amplitude. So I'll put a 1 here, a -1 there. And I'll call that halfway, let's call that the full period, pi. I wanted to get a nice half right there. So that's half the way, and that's my whole period of pi. So I have my parameters for graphing this. I now want to graph cosine. So cosine with an a value that's positive, I'm going to start here at 1, which means I'm also going to end at 1, which means I'm going to drop down to my lowest point halfway through the period. So I start at 1, end at 1. Halfway through, I drop to my lowest point, which is an amplitude of 1 down. Halfway between each of these, aren't we going to have our asymptotes? Now you might wonder, why do we have an asymptote? Well, let's sketch cosine. Let's sketch it to see it. If we sketch cosine, do you see how cosine right there? I sketched cosine. Do you see how we hit the x-axis at those two asymptotes? That's why we had what we did. So at this point, aren't we going to go up like that for secant? At this point, to mirror what we had for cosine, or to do its reciprocal, won't it look like that? And won't this part look like that? So this normally goes down, so it's going to do the reciprocal. Normally looks like that, so it's going to do reciprocal. Normally looks like that, so it's going to do reciprocal. That right there is that graph.